So we're continuing with our algebra review. This is like the next step after we factor, okay? And then also using the property of square roots to solve. So instead of just factoring and leaving it in the parentheses, we're now going to say what x would equal. So we take it to the next step. If you are factoring, then we're going to get all the terms to one side. So for me, as soon as I see like an x squared and an x, I know I'm probably going to at least try to factor it first. And so I get everything to one side. And then you're going to factor the equation whichever way you can. So whether that's factoring out the greatest common factor or difference of two squares or perfect square trinomial, any of the ways that we reviewed last week to factor, you'll factor it. And then you'll split and solve by setting each of those terms or parentheses equal to 0 and solving them. For a lot of these, you'll have two answers. It doesn't mean there's always two answers, but for a lot of them, there are two answers because they started as an x squared. Sometimes it's the same answer. Sometimes there are two different answers, but usually there's two. So the directions will now say solve. There's two major differences. One is the directions change. It will now say solve. The other is that you will have an equal sign in these questions. There was not an equal sign from last week. It was just factor. So I look at the first one. I want to make sure it's set equal to 0, and it is. Actually, let me number this instead of this is number 1. It is already set equal to 0, and then I want to see if it can be factored. This one is already factored, so I just split and solve. I would set x equal to 0 and x plus 3 equals 0, and then subtract the 3, and x is negative 3. The other one's already solved for 0. So x would equal negative 3 and 0. Go to 2. Again, already set equal to 0 and already factored. So split and solve. Set 5x equal to 0 and set 3x minus 2 equal to 0. So if I want to isolate the x on the left, what do I do? Good. Divide both sides by 5, and 0 divided by 5 is 0. And then on the right-hand side, I want to add the 2. I'd get 3x equals 2 and divide by 3. And x is 2/3. So my two answers would be 0 and 2/3.
Why is there like two equations?
Because it's an x squared, right? Or two separate terms. This one's already factored. Eventually, we're going to have to factor it. But if I had distributed it, it would be an x squared, which means there should be two values for x. All right, then you get to questions like these. So it would be the same set of instructions. The goal at the end is still the same. The difference is they're not already factored. The first one, at least, is already still set equal to 0, so I don't have to do anything at the beginning. But then I have to get this into its factored form. So I look at the x squared minus 5x plus 6. It's not two terms. I can't factor anything out, right? That's 3, not a perfect square trinomial. So the goal here is to find the factors of the last number that sum to the middle one. What are the factors of positive 6 that sum to negative 5? Good. Negative 2, negative 3. I think 6 is the most commonly mistaken one because of that, because it's 6 and 1 and 2 and 3 both. But you got to watch your signs. Because the last term is positive, they both have to have the same sign. And then we split and solve here. And I'd get x equals 2 and x equals 3.
What about the x squared?
We're factoring it.
I know we have 3 x's, so like...
No, we have 2 x's. From here, we factored to here. So that's the same thing we were doing last week. We just now said, what do I do after that? So if this says x squared here, there should be 2 answers. Sometimes they're the same answer.
When you put like the comma between the 2 and 3,
You're just like listing what the values of x could be.
it's like 3 and 2 doesn't matter.
Nope. No. If it said like I know like the online platform for Algebra 2 sometimes says like put them in order of least to greatest. Obviously then it would matter, but it's not gonna, I don't think Big Idea says that one. You're just entering it. And these are easy to check if you have the extra time. So like let's say we fast forward to Friday and there's a little bit of extra time and you want to check. You could take these values, then plug them back in. So if I were to plug 2 back in, I would get 2 squared minus 5 times 2 plus 6 equals 0.
Wait, what about 3?
I'm going to do that after. And then I get 4 minus 10 plus 6 equals 0. 4 minus 10 is negative 6, and negative 6 plus 6 is 0. So as long as you end up with a balanced equation at the end, you know that that answer works, so that one is right. And then you can do the same thing with the 3. 3 squared minus 5 times 3 plus 6 equals 0. 9 minus 15 plus 6 equals 0, and negative 6 plus 6 equals 0. So let's just say, and the quiz isn't going to be multiple choice. Let's just say you get this on a standardized test question, and it's multiple choice. You could actually, if you are unsure about the factoring method, you could always take your answers and plug them in until you find ones that work. I think that takes longer than actually factoring here. Yep.
0.
Questions on that one? Okay, so now if you go to the next one, we'll call this number 4. What's different this time?
The 15 go on the other side.
Good. It's not like it's 0 not on the side by itself. So the first thing I have to do is move that 15 over. I'm going to add the 15 to both sides. I get x squared minus 8x plus 15 equals 0. And now I want to factor.
Negative 5 and negative 3.
Good. And then split and solve. X equals 5 and x equals 3. All right, so now we're on the 5th one. Okay, so same first step, make sure it's equal to 0, and it is. And then there's 3 terms. Can I factor something out?
1.
Well, that's a no. Like other than 1. 1 doesn't help, right? If they were all divisible by 2 or something, then I would take that out. But you can't, which means this is the one where if I have the term on the front, I either have to do first and last or trial and error, okay? So I'm going to multiply 3 times negative 8, because most of you do first and last. That's negative 24. Find the factors of negative 24 that sum to negative 2. Good. 4, negative 6. Replace your middle term with those, so x or 3x squared plus 4x minus 6x minus 8 equals 0. And then factor by grouping. So for the first one, I'm going to take out the x. I get 3x plus 4. The second one, I want to change the sign so it matches and take out a 2. So negative 2, 3x plus 4. And then the 3x plus 4 repeats, so I take that out and I group together the x minus 2. Then split and solve. So I would subtract the 4 and divide by 3. And then add the 2. Yep. Why? Because you're in your middle term. Which one? Because you mean from the beginning up here?
Yeah.
It has to multiply together.
Without doing first and last.
You can't. If you do trial and error, is that what you mean? Yeah, no, you can't. You can't ignore that 3. That 3 has to be part of it. All right, what is this? 6. Okay, this time we have to move that 3 over because that has to be equal to 0 before I can factor. 2x squared minus 5x plus 3 equals 0. And then we could do trial and error this time because those are prime. 2x squared would be 2x and x. And then 3, the only options for a positive 3 that result in a negative in the beginning is negative 1 and negative 3. Do outer and inner here, negative 6x minus 1x, that's negative 7. Doesn't work, so we switch these. 3 and 1, and there I get negative 2x minus 3x, which is the negative 5x. So I know that's the combination that works. And I split and solve. So on the left, I add the 3 and divide by 2. And on the right, I add the 1. All right, the second method to solving, so by the time we get through tomorrow, there's going to be 3 total. That first one is by factoring. The second one is using the property called the even root property, okay, which is by using the square root property. Now that square root property says, like, if I had x squared equals 25, and I wanted to figure out what could go into that x, both positive and negative 5 can be plugged in. If I do positive 5, I square it, I get 25. Negative 5, I square it, I also get positive 25. So the rule is when there's hold on 2 seconds. The rule is that if you have an x squared or a variable squared, and you go to square root both sides of the equation to get rid of that square root, that you have to put a plus and minus in front of the numeric side. So this would result in it getting x equals plus and minus 5. So there are 2 answers there, negative 5 and positive 5. Mateus, you had a question? Sure. This does not mean that the square root of 25 equals positive and negative 5. The square root of 25 is just positive 5. Only when you bring in the square root to solve for a variable can you use both, okay? So if it just said square root of 36, my answer is not positive and negative 36. But if it said, positive negative 6. But if it said x squared equals 36, now my answer is negative and positive 6. So this is not the same thing.
Because negative 5 squared is 25.
Correct. And so is 5 squared. All right, so our goal here is to isolate the x squared. And this is, you'll know the difference. You can actually do these 2 ways, but for these examples, and I'll show you 2 ways in a little bit. But for when you only have an x squared, you don't have an x squared and an x, you only have an x squared, you use that square root property. So what number are we on? 7? Yeah. So for this one, x squared is on the side by itself. I'm going to square root both sides to get rid of it, but I'm putting the plus and minus in front of that 4. Or root 4, and I get x equals positive and negative 2. Now, if this is like an open-ended short answer question, you can leave it just like that. You could literally leave it as plus or minus 2. If it asks you to answer it as a comma separated answer, then you're going to separate it out, negative 2, comma 2. Okay, look at the next one. So we could do what we just did, and your answer would be what? Good, positive and negative 3. Or I can factor this because it is the difference of 2 squares. This only works on the perfect square ones. If I were to subtract 9 so that this was x squared minus 9 equals 0, that's the difference of 2 squares, right? So when I factor this, I get the x in the first spot, the square root of 9 in the second spot, which is 3, and 1 gets a plus and 1 gets a minus, and split and solve. You get x equals negative 3 and x equals positive 3.
You just did like an extra step.
Well, you just did it a different method. Both would give you the same answer.
I agree to throw x equals 3.
Okay.
I think the first one's slightly better.
Thank you for your feedback. All right. So now looking at that, this would be 8. I can, this time it's already on that side, right? So I could factor this into its difference of 2 squares, or I can add the 36 to the other side and isolate the x squared. So you get to choose. Both will give you the right answer. And it only works both of those ways because there's only an x squared and a perfect square. If it's not an x squared, if there's an x squared and an x, you can't do it. And if the second number is not a perfect square, then you can't factor. You have to use the square root property, which is the next one. So I can't factor x squared plus 10. If I isolate, meaning I'm going to move the x squared or the negative 10 to the other side, and then I square root, I'd get plus and minus the square root of negative 10. Can you square root a negative number? No.
No.
It's actually no real solution. There are imaginary solutions, but there are no real solutions to that one. Yep.
Can't factor. This is a perfect square.
You can't factor because two things. It's not a perfect square, and it's not the difference. In order to factor, it has to be the difference of two squares. So even if that's at x squared plus 25, there still would be no solution here.
So it has to be minus all the time.
It has to be what? If you're gonna use the square root, yeah. I mean, if you're gonna factor, use called the difference of two squares. It has to be a minus.
So every time it's plus, it's negative.
If it's x squared plus something, yes. What are we on? 9? No, 10. Okay. X squared minus 17 equals 47. So the first thing you're going to do here is what? And you have two options, actually. I can move the 17 to the other side. X squared would equal 64. And then square root both sides, putting a plus and minus in front of the square root. And I get x equals plus and minus 8. Again, you can keep it together if it's short answer. If it was something you have to type in separated, make sure you separate it out. Your other option is, again, only when it's an x squared and a number. You can't do this with it was an x squared and an x, but I can move that 47 to the left, and I would get x squared minus 64, which is the difference of two squares. All right, so give me one way to set up 12. I can, okay, you both gave, good. One way is I can isolate the x squared, and the other way is to factor the different two squares. I'm going to show you both ways. I don't care which one you pick, as long as you pick one, okay?
Which ones do you say is better?
I actually think probably for those of you that are a little bit shaky on square rooting with fractions, the first option is going to be better, but it doesn't always have to go that way. So this is the difference of actually, there's three ways to do this. This is one, the difference of perfect squares. So this would be 2x and 2x, positive 12 and negative 12, and then split and solve. I would subtract the 12 and then divide by 2. Same exact process on the other side. Add the 12, divide by 2. So solutions there, negative 6 and positive 6. That's first method, difference of two squares. Second method, still keeping with factoring, is I can actually take out a 4 here. 4 comes out, and I'd get x squared minus 36. And then I have x plus 6 and x minus 6. Now, when I split and solve here, there's an extra term on that front, okay? But if I were to set 4 equal to 0, can that ever happen? Can 4 itself equal 0? No. So if there's a numeric value by itself, if it's just a number and not with an x, I literally ignore it. I could have divided the whole thing by 4 and it would have gone away. Then I just have to split and solve these. And I get x equals negative 6 and positive 6.
Can I do it like this?
Hang on, Mars. So if I take out the 4 from the beginning, if I had taken out a 4x, now I have to have it set equal to 0, and that's an answer. But if I take out just a value, a numeric value, then I can ignore it. The other option is take your 4x squared minus 144 equals 0. Add the 144 to the other side. 4x squared equals 144. Divide both sides by 4. X squared equals 36. Square root both sides, putting a plus and minus in the front.
No, just the easiest. That's what I did.
Now, the only reason that process gets tricky is if that 4 didn't go in evenly into the 144. So if it doesn't go in evenly and you're square rooting a fraction, remember that you can't leave a square root in the bottom. You'd have to rationalize it. So that's the only time I would say that gets trickier. Okay.
You can't use calculators in this test.
Nope. Questions so far? All right, last set of slides, 13, 14. Or last set of examples. All right, so this is, again, you could overcomplicate this. I would not recommend this. I could expand and FOIL the left side, move the 9 over, and refactor it. Don't do that, okay? You could, but don't. The other option is that is one term squared. So if I want to get rid of it, even though it's two terms inside my parentheses, this like is working to group this together, I can square root this whole side and this whole side, putting a plus and minus in front of the 9. The square and the square root cancels out, and I get x minus 2 equals plus and minus the square root of 9, which is what?
3.
Good. And then my last step here would be to add 2. Now there are 2 answers there. One is 3 plus 2, and the other is negative 3 plus 2. So I'd get 5 and negative 1. Again, you could have, like I could have used this special product here to expand this. It would have been x squared minus 4x plus 4 equals 9. Subtract the 9. X squared minus 4x minus 5 equals 0. And x minus 5, x plus 1 is how we would factor it. And I would get x equals 5 and x equals negative 1. I would obviously stick with the first method. Just don't forget your plus and minus. All right, last one. What am I going to do there? Square root both sides, putting the plus and minus in front of the root on the 25. I get 2x plus 1 equals plus and minus square root of 25 is 5. So now I can split it here, and I can do 2x plus 1 equals negative 5, and 2x plus 1 equals positive 5. Or I can keep going. Just be really careful when you're adding and subtracting on that other side. So if I split it, I get negative 1, negative 1. So 2x would equal negative 6, divide by 2. And x is negative 3. And on the right, subtract the 1. 2x equals 4, divide by 2. And x equals 2.
So what would the other be?
I would have done, you mean from here?
Yeah.
I would have taken plus and minus 5, subtracted 1, so this is gone, and then divided by 2. But then you still have to separate it out. You still have to do positive 5 minus 1 divided by 2, and negative 5 minus 1 divided by 2. So you still end up doing the work at the end. It's just without the x at the end. Questions? All right, big ideas assignment should be open. Make sure you're showing your work for these. Obviously, if it says x squared equals 36, and you can put plus and minus 6, you don't need work on that stuff. But everything else, all the ones that you're factoring, you need to show the work.